Hello and welcome to the second lesson in applications generation. Today we're going to be looking at open versus closed source software. Computer programs are typically written in a high-level language, Java, C#, VB, something like that. This code, is what is known as the source code. Source code is human readable, especially if you understand programming, and it can be edited and changed very easily. When the code is run, however, the source code needs to be translated into what we call machine code, ones and zeros. This creates an executable file that the CPU can run, but is difficult for people to understand. This machine code cannot be edited and changed easily by people. When software is sold commercially, it is typically the executable machine code file that is distributed. This means people can run it without having to worry about translating the program. Also, let's face it, most users have no need for a programmed source code. Big businesses often believe that it would be foolish to distribute the source code, as it would mean users could amend and edit their software and steal their work. This model of software is known as closed source or proprietary software. There are many examples of closed source software. Most of the big software programs that you're aware of will almost certainly be closed source. So things like Microsoft Windows, Microsoft Office, Adobe Photoshop, most of the games that you play are all examples of closed source software. You get the executable machine code file that you can run on your system, but you don't get the source code, the program file that means you can kind of look under the hood and see how everything works. That is kept by the big software company. You don't get to see it. There is another type of software that we call open source software, OSS, where the source code is made publicly available along with the machine code version. This means that users could download the open source version and modify the software to suit their needs, or get somebody else to make those changes for them, and then translate that into machine code and run it on their computers. It means that anyone could have a part in the development of a new piece of software. There are some very famous examples of open source software. Linux and all the different versions of Linux are all open source software. So if you've got Linux Ubuntu or Linux Mint or any other form of Linux, including the Android operating system used on Google phones and Samsung phones and things like that, that is all open source. Firefox web browser is open source, LibreOffice, OpenOffice, these are all open source applications. So as I say, one of the best pieces and most well-known pieces of open source software is the operating system Linux. There are many different variants or forks of Linux, and one of these was used as the basis for the Android operating system. So somebody took Linux, they forked it, and they ended up creating a special version of Linux for mobile devices called Android. This was later purchased by Google, and Google have been using that for many years as their operating system of choice for smaller devices. There are many advantages and disadvantages to using open source software. One of the biggest advantages is the price. As the source code for open source software is freely available, there's usually little point in charging for a copy of it. Therefore, most open source software, but not all, is freely downloadable. However, don't think that you can't make money from open source software. Some companies can make a lot of money from it by offering the product for free, but then they charge for technical support to businesses that want it. So something like Red Hat Linux, for example, is a special version of Linux. The company behind it make a lot of money by charging technical support because big businesses who are running that version of Linux want somebody to help them if they have any problems. Open source projects tend to be supported by an army of volunteer coders and testers. While these people are often very competent programmers, sometimes exceptionally competent, they don't always have the resources and organization available to a big software house's paid programming team. For this reason, some open source projects can lack the polish of their commercial closed source counterparts. So often open source software doesn't have such a nice user interface. It doesn't look quite as attractive because they have less time and effort and energy spent on that part of development. On the other hand, large open source projects have many programmers and testers working on them, which means the software can be quickly and regularly updated. Basically, anybody who finds a bug can fix it and upload the new version of the code. Whereas if you're looking at closed source software, you have to wait until the big company decides to release a patch or a new version that fixes the error. So the question as to whether open source software systems are more or less secure than closed source software is subject to a lot of debate. Some argue that as the source code is freely available with open source software, anybody could find security holes in the code and exploit them. However, the proponents of open source would counter that this is what makes open source software so secure. There are so many people checking and verifying the code that such security holes can be found and corrected exceptionally quickly. So here we've got a basic summary of the difference between open source and closed source software. Feel free to pause the video, make some notes here. I'm not going to go through it all step by step. These are some good general ideas that you can use in an exam, especially if you get one of those 10 or 12 markers. So in summary, open source software is where the source code for the software is freely available for download. You can edit, change it, do what you want with it. Whereas with closed source or proprietary software, the source code is kept essentially secret. It's not available to typical users. You can use the software, but you can't make changes to it. Please remember that in the exam, there's no kind of one is good and the other is bad. You're always looking at weighing up strengths and weaknesses for different situations and be very balanced in any arguments that you make. Hope that was helpful for you. I will give you another video next week. Good luck with your studies.